Case study: Enhancing Cybersecurity with Neural Networks, a Dynamic and Adaptive Approach at TechCorp. Cybersecurity threats are evolving at a breakneck pace, and traditional defense mechanisms are often left wanting. Enter neural networks, a transformative force offering dynamic and adaptive solutions against cyber threats. In this case study, we explore how TechCorp, a leading technology company, leveraged neural networks to safeguard its digital infrastructure in an increasingly hostile cyber landscape. TechCorp, a multinational enterprise with a vast digital footprint, faced myriad cyber threats daily. The company's cybersecurity team, led by Chief Information Security Officer Ana Rodriguez, had long relied on traditional rule-based systems to defend against attacks. However, as the sophistication of cyber threats grew, these static systems frequently failed to detect new and emerging threats. Recognizing the limitations of their current approach, Ana and her team decided to explore the potential of neural networks to bolster their cybersecurity defenses. The team began by investigating how neural networks could be integrated into their existing security infrastructure. One of the key areas of focus was malware detection. Traditional signature-based methods were increasingly ineffective at identifying new malware variants. By contrast, neural networks offered the ability to learn the underlying features and behaviors of malware, enabling the detection of previously unseen threats. Ana and her team collaborated with data scientists to train a deep neural network using a large dataset of known malware samples. The results were promising, with the neural network achieving higher detection rates and lower false positive rates than the signature-based methods they had been using. Can neural networks truly be more effective than traditional methods in detecting new malware variants? The study by Sachs and Berlin provided compelling evidence that deep learning models could outperform traditional signature-based approaches. The neural network developed by TechCorp's team successfully identified several new malware strains that had evaded their previous detection systems, validating the potential of this technology in enhancing malware detection. Next, the team turned their attention to phishing attacks, a prevalent and evolving threat. Phishing emails were becoming increasingly sophisticated, making it difficult for conventional filters to distinguish between legitimate and malicious messages. Here, the team employed recurrent neural networks, known for their prowess in processing sequential data, such as the text found in emails. Training the RNN on a vast corpus of phishing and legitimate emails, the network learned to recognize subtle patterns indicative of phishing attempts. A study by Bonson et al. Reported similar findings, with RNNs achieving a detection rate of over 90% while maintaining a low false positive rate. Can neural networks effectively distinguish between legitimate and phishing emails? The implementation at TechCorp demonstrated that RNNs could indeed achieve high accuracy in detecting phishing emails, significantly reducing the number of successful phishing attacks against the company. The RNN flagged numerous phishing attempts that had previously slipped through their defenses, preventing potential data breaches and financial losses. Another critical area of focus was network intrusion detection. TechCorp's intrusion detection system had historically relied on predefined rules to monitor network traffic. However, sophisticated attackers frequently found ways to circumvent these static rules. Ana's team sought to leverage neural networks to enhance their IDS by learning the normal behavior of network traffic and identifying anomalies indicative of potential intrusions. They employed a deep learning-based IDS, testing its effectiveness on a benchmark dataset. The results were significant, with the deep learning model achieving high detection rates and low false positive rates, as demonstrated by Vinayakumar et al. How can neural networks improve the accuracy of intrusion detection systems? By learning the normal patterns of network traffic, the deep learning-based IDS at TechCorp was able to detect deviations that traditional systems had missed. This capability allowed the team to identify and mitigate several intrusion attempts in real time, enhancing the overall security posture of the organization. The dynamic nature of neural networks was another major advantage. Traditional defense mechanisms often struggled to keep pace with rapidly evolving cyber threats. In contrast, neural networks could be continuously trained and updated with new data, allowing them to adapt to emerging threats. Anna's team implemented a process for regularly updating their neural networks with the latest threat data, ensuring they remained effective against new types of cyber attacks. For instance, by training the neural network on data from recent ransomware attacks, the team was able to quickly identify and respond to new ransomware variants. Can continuous training of neural networks ensure they remain effective against new threats? The adaptive capability of neural networks proved invaluable at TechCorp. By regularly updating their models with new threat data, the team was able to maintain a robust defense against the latest cyber threats, significantly reducing the risk of successful attacks. However, the implementation of neural networks in cybersecurity was not without challenges. One of the primary concerns was the potential for adversarial attacks, where attackers deliberately manipulated input data to deceive the neural network. Anna's team was well aware of the research by Goodfellow, Schlenz, and Seghetti, which highlighted the vulnerability of neural networks to such attacks. To mitigate this risk, they employed adversarial training, where the network was trained on both legitimate and adversarial examples. This approach helped the network become more resilient to adversarial manipulation. How can organizations protect neural networks from adversarial attacks? By incorporating adversarial training, TechCorp's team was able to enhance the robustness of their neural networks, reducing the likelihood of attackers successfully deceiving their defense systems. Another significant challenge was the interpretability of neural networks. Deep learning models, particularly those with many layers and parameters, were often considered black boxes due to their complex and opaque decision-making processes. This lack of transparency was problematic in cybersecurity, where understanding the reasoning behind a detection was crucial for effective incident response. To address this issue, Anna's team explored explainable AI techniques, which aimed to provide insights into the decision-making processes of neural networks. By implementing XAI, the team could better understand why the network flagged certain activities as suspicious, enhancing the trust and reliability of their systems. How can explainable AI improve the effectiveness of neural network-based cybersecurity solutions? The use of XAI at TechCorp allowed the team to gain valuable insights into the decision-making processes of their neural networks, improving their ability to respond to security incidents and fostering greater trust in the technology. The quality and diversity of training data were also critical to the success of neural networks in cybersecurity. A neural network trained on a limited or biased dataset might fail to generalize to real-world scenarios, leading to poor performance and increased false positives. To ensure access to high-quality, representative datasets, Anna's team collaborated with industry partners, academia, and government agencies. This collaboration facilitated the sharing of relevant data and knowledge, fostering the development of more robust and effective neural network-based security solutions. What role does data quality play in the effectiveness of neural networks in cybersecurity? TechCorp's experience highlighted the importance of high-quality, diverse training data. By collaborating with external partners and accessing comprehensive datasets, the team was able to train more effective neural networks, reducing false positives and improving overall performance. In conclusion, TechCorp's journey illustrates the transformative potential of neural networks in enhancing cybersecurity. By leveraging neural networks for malware detection, phishing prevention, and network intrusion detection, the company significantly bolstered its defense mechanisms against a wide range of cyber threats. The adaptability of neural networks, their ability to learn complex patterns, and their capacity to analyze vast amounts of data in real time were instrumental in achieving these results. However, challenges such as adversarial attacks, interpretability, and data quality must be addressed to fully harness the benefits of neural networks. Through continuous research, collaboration, and the implementation of advanced techniques, organizations like TechCorp can stay ahead of evolving cyber threats and ensure the security of their digital infrastructure.